Okay, so let's have a look at what we are really interested in, which is the CFA in relation to the different groups that we have in our data. And as you remember, there are two different ways of how we can do this. One is we run the CFA by group, so we go step by step. For example, the structure equivalence, we specify first the group, then we go for the metric model where we specify that we want to constrain the loadings to be equal, and then we go for the full kind of scalar invariance model where we constrain both the loadings and the intercepts to be equal. We can do this, or we can also can test this overall with one single step where, like we run the, for example, the cross-cultural psych package with the equivalence, the equival function, right? So if I want to, like I just want to start off and go with that particular option, and then see, like whether we need to go through some of these other steps separately, right? So if I would, for example, run this model right now, I will get the following output. And just to show you again that, like the analyses and the write-up can be actually quite straightforward, right? So if I go back here to my little output that I started creating, we tested a multi-group CFA model to test the measurement properties. We used the for example, in our case, we used the CC Psych package reference in our reference to test configural metric and scalar invariance. So now you need to actually quickly explain what this is. I'm not going to do this right now. I'll just put here explanation of invariance tests and their relevant steps. Right? So this is something that you would need to put here if you have not in your thesis put it earlier on in your method section, for example. So the first thing is the configural model is always the baseline model, right? So that tells us something about how well the model fits overall. The configural invariance test showed acceptable fit. I'm jumping ahead here a little bit. By the way, we will get to some important information that is that we still need here. So we need the chi-square, and we don't have it yet. The CFI is there. The CFI is what? It's 0.96. We need the, ideally we would want to have the TLI as well. We don't have that here. The RMSEA is often used, so 0.0. I will go with 3 decimal places right now for the RMSEA, because actually for both of them, because if you remember, values smaller than 0.001 are informative for these changes as we go for and test more restricted models. So the RMSEA is there. Then we want to also look at the SRMR. The SRMR is 0.039, so pretty good. We would need to get the chi-square. The chi-square, for that we need to go back up here, specify our model. Oops, what happened here? And then run it. Our chi-square overall is here. So we would need the chi-square. Degrees of freedom are 212. The chi-square itself is 1598.79. Right. When constraining the vector loadings to be identical across, or equal, to be equal across groups, now we need to look at both the fit indices as well as the change in fit. Right, the overall fit by itself was still acceptable. So we need to get chi-square, degrees of freedom. We will need to get this in a second. CFI equals 0.955 with rounding. RMSEA equals 0.076. SRMR equals 0.045, actually with rounding 6, right? And the change in fit was, and here we then need the change for the chi-square, we need to change for the CFI, and we also want to change in RMSEA. So we don't have to change in chi-square yet. So we first of all just focus on the CFI. Fit was 0.001 for the CFI and 0.004 for the RMSEA. We could also look at the gamma or McDonald's non-centrality index. Both of them have been discussed in the literature. I quite like them, but the most common ones are the CFI and the RMSEA. So just looking at these, the change is actually smaller than 0.01, so it is pretty good evidence that we have equal vector loadings. As I said, we need to have the we need to get the chi-squares as well. So if we go here, we get our chi-square. So for the overall chi-square, we have 242 for degrees of freedom, and it's 168,108. And we obviously also want to have the difference in chi-square. And fit was, in this case, 82.285, which is p degrees of. So we could have the delta sign for degrees of freedom is 30 here, and p is smaller 0.001. And then, so basically our sentence, the change in fit was 0.8. The change in fit for the chi-square was 0.0, which is significant. 0.01 for the CFI and 0.04 for RMSEA. Based on the overall pattern, we can assume that metric invariance was met because the CFI and the RMSEA look pretty good. So now we can proceed and test full score or scalar equivalence. So if we go back up to our output here, just bear with me, we're getting there, we're getting there, we're getting there, we're getting there. Voila, there we are. So when constraining intercepts to be equal across groups, our fit indices were, we need chi-square with the degrees of freedom. We will get that in a minute. CFI is 0.944. RMSEA is 0.0799. It's actually, if we round it, it's 0.08, and SRMR is 0.0499. So basically 0.5 again here. The change in fit was for chi-square, so if we need to get that still, we have the CFI 0.011 for CFI, and for the RMSEA we have a negative value, actually 0.044 for RMSEA. Why do we have a negative value for RMSEA? If you remember, RMSEA rewards more parsimonious models. So right now we have a more constrained model, so we actually have a simpler model because all the intercepts are exactly the same or set to be the same across the different groups. Therefore, this model is simpler, more concise, and that is something that the RMSEA rewards. So we will get into a very interesting dilemma actually in just 1 second. Let me just get all the missing information from the chi-square values here. So if I run this model up here and we get our chi-square, actually we could just make it much simpler. So the scalar chi-square here is 1982. So the degrees of freedom for the overall fit are here. So it's 272. The chi-square itself is 982.8. And then we need also the difference in chi-square. The change in fit was 301.69. And we need, of course, also the change in degrees of freedom. Delta is the sign for change. Again, it's 30 for chi-square 0.01. Alright, so what can we make from this, from these results here? Our chi-square is quite large. The CFI is a bit below our desired cutoff. RMSEA is right on the border. SRMR is still pretty good. It is below the threshold that Hugh and Bentler were talking about in their simulation models. Simulation study. The change in fit for the chi-square is actually quite large. It's we need, of course, also the p-value here. P small m point. Oh, look, this is a pretty small p-value here. For chi-square, and it's above the threshold for the CFI, and we have a slightly better fit for the RMSEA. If we just go quickly back to the output here. In a case like this, I would also look at the change in gamma and the change in the non-centrality index. So as you can see, the non-centrality index overall is not that good. The change, the gamma itself is pretty good for the model itself. If we look at the change between the metric and the scalar model here, what you can see, the gamma is pretty good, but the non-centrality index there is not so good. The cutoff value here is 0.02, and I would actually say, based on all this evidence, we don't quite have full score or scalar equivalence here, right? So if we wanted to, and it's up to you, you could actually, for all of these indices here, you could include gamma up here, and you could McDonald's non-centrality index. So, or we could just MNCI equals the change in fit. So we would need to include the change in fit for these other two indices, right? So it would be 0.0 here. Would be 0.002 for gamma and 0.05 for McDonald's non-centrality index. So again, that shows very clear evidence that metric invariance was met, but when we constrain it to be the same, the intercepts to be the same, so we would include the gamma here and the MNCI here. So we would get these values here and then also include these changes here. So the gamma equals 0.06 and MNCI was 0.026. In balance, the chi-square, the CFI, and the MNCI suggested that metric invariance was not met, whereas the RMSEA and gamma suggested scalar invariance was not met, whereas the suggested scalar invariance was met. So what I would suggest in this case here is that we are really looking at a borderline case. You could now look at further information, so you could run your modification indices and see whether there's some of these values that could be freed up. And so this is really where detective work would start in order to really work out what's happening here. What we can conclude for sure is we have metric invariance, so the vector loadings are the same across the 4 different groups, but we cannot be 100% certain about full score or scalar invariance yet. I hope that makes sense. And again, so this is, if you want, this is what a rough draft of your multi-group CFA would look like. So you need to get all the relevant information out. You need to put it, maybe in a nicer form than what I put here, and then you need to interpret that. So the interpretation is really something that is important. What that does that now mean for our instrument and for any kind of comparisons that we can run.